Welcome to this lesson on direct and inverse proportion. By the end of this video, you will be able to express proportional relationships using algebraic equations and solve IGCSE exam-style questions involving linear, square, and root relationships. In mathematics, proportion describes how one variable changes in relation to another. Whether we are talking about the cost of items in a shop or the way gravity pulls on an object, these relationships follow specific algebraic rules that we can master. Let's start with direct proportion. We say two quantities are in direct proportion if they increase or decrease at the same rate. Our goal is to learn how to define and express direct proportion algebraically. When we say y is directly proportional to x, we use a special Greek symbol called alpha. This statement, y alpha x, means that as x doubles, y also doubles. However, to do any actual math, we need to turn this into an equation. We do this by introducing a constant of proportionality, which we call k. So, y equals k times x. Here, k is just a fixed number that links the two variables. Graphically, direct proportion is always represented by a straight line passing through the origin. The gradient of this line is our constant, k. In your exams, the first step is almost always to find the value of k using a pair of known values. Once you have k, you have a formula that works for any value of x or y. Now, let's look at inverse proportion. This occurs when one value increases while the other decreases. Think of speed and time. If you travel at a higher speed, the time taken for your journey decreases. We say y is inversely proportional to x. In algebraic terms, we write y alpha 1 over x. This tells us that y is proportional to the reciprocal of x. Just like before, we replace the alpha symbol with an equals sign and a constant k. This gives us the equation y equals k divided by x. The graph of an inverse proportion is a curve called a hyperbola. Notice how as x gets very large, y gets very small, and as x gets close to 0, y shoots up towards infinity. Whether the relationship is direct or inverse, your strategy remains the same. Write the proportion, create the equation with k, and solve for k using the given data. In the IGCSE syllabus, proportion isn't always linear. You will often see relationships involving squares, cubes, or roots. Our learning goal for today is to apply proportion rules to square and cube relationships. Let's look at an example involving a square. If we are told that y is proportional to the square of x, we write y is proportional to x squared. Converting this into our equation format, we get y equals k times x squared. What if it is a root? If y is inversely proportional to the square root of x, the notation looks like this. Y is proportional to 1 over the square root of x, which becomes the equation y equals k divided by the square root of x. Take a moment to look at these common forms. Linear, y equals kx. Square, y equals kx squared. Cube, y equals k times the square root of x. Inverse square, y equals k over x squared. The language in the question tells you exactly how to set up your initial equation. Whether it is a square, a cube, or a root, the process of finding k remains exactly the same. Now, let's work through a typical IGCSE exam question. These are usually broken into 2 or 3 parts. Our question states, y is directly proportional to the square of x. When x equals 3, y equals 36, we need to find an equation for y and then calculate y when x is 5. Step 1 is always to write the relationship using the alpha symbol. Since it is direct proportion to the square of x, we write y alpha x squared. Step 2 is to turn this into an equation with our constant k. Step 3 is to substitute the values we know to find k. The question says, when x is 3, y is 36. This simplifies to 36 equals 9 times k. To find k, we divide both sides by 9. So k equals 36 divided by 9, which gives us k equals 4. Now we can answer part A. The equation for y, in terms of x, is y equals 4 times x squared. Finally, for part B, we use our new formula to find the unknown y when x is 5. Substitute 5 into the equation. Y equals 4 times 5 squared. This becomes y equals 4 times 25, which results in y equals 100. By following these steps, you've turned a word problem into a precise mathematical tool. Let's try a more challenging example involving inverse proportion and a cube root. This often catches students out, so pay close attention to the setup. Here is our question. P is inversely proportional to the cube root of Q. When Q equals 8, P equals 5. Find the value of P when Q equals 125. First, we write the relationship. Because it is inverse, the cube root of Q goes in the denominator. Next, we introduce the constant K to create our equation. Now we substitute our known values. P is 5 and Q is 8. Since the cube root of 8 is 2, we can simplify this. Multiply both sides by 2 to solve for K. We now have our master formula for this specific problem. The final step is to find P when Q is 125. We know that 5 times 5 times 5 is 125, so the cube root of 125 is 5. And 10 divided by 5 gives us our final answer. P equals 2. Notice how the steps remain identical to the previous example. The only thing that changed was the algebraic power we applied to the variable. In this final example, we will look at a common exam variation, finding the value of the independent variable, which requires a bit of algebra to rearrange the equation. Here is the question. M is directly proportional to the cube of R. When R equals 2, M equals 40. Find the value of R when M equals 135. We begin by setting up the proportional relationship. M is proportional to R cubed. Now, we convert this into our equation using the constant K. M equals K times R cubed. Next, substitute the initial values. M is 40 and R is 2. This gives us 40 equals K times 2 cubed, which simplifies to 40 equals 8K. Divide by 8 to find the value of K. K equals 40 divided by 8, so K equals 5. Our completed formula is M equals 5 times R cubed. Now for the final part, find R when M is 135. We substitute 135 into our equation. 135 equals 5R cubed. To solve for R, we first divide both sides by 5. 135 divided by 5 equals R cubed, which means 27 equals R cubed. To find R, we need to take the cube root of both sides. R equals the cube root of 27, which is 3. Let's summarize the steps we've used. 1. Write the relationship with alpha. 2. Replace alpha with equals K. 3. Solve for K using given values. And 4. Use the formula to find the final unknown. By consistently following these 4 steps, you can solve any proportion question the IGCSE exam throws at you. You have now mastered linear, square and root relationships in both direct and inverse forms.